Welcome to a Math Help Central video. In this series, I will go over all the topics you will need to know for the AP Calculus AB exam. First, we will go through an overview of limits. We will also go through a few examples of limit-related problems you might find on the exam. So what are limits? Let's say the question asks you to find the limit L of f of x as x approaches a. If a equals 0, L would be the number f of x approaches, as x gets closer and closer to 0. For this graph, the limit would be -1. And this is basically just a visual of what I said. You might be asked to find the left and right hand limit. The left hand limit is what f of x approaches as x approaches a from the left. The same goes for the right hand limit, except this time, x is approaching a from the right. But sometimes the left hand limit, and the right hand limit, are different numbers. Take this graph for example. The left-hand limit as x approaches 0, is 1. But the right-hand limit as x approaches 0 is 0. Therefore, we say that the limit at x equals 0 does not exist. Remember, in order for a limit to exist at a point, the left-hand limit of that point must equal the right-hand limit of that point. Let's take a look at some examples where we find limits based on graphs. Find the limit of f of x, as x approaches -1, 0, and +1. If the limit does not exist, put dne. The left-hand limit as x approaches -1 is positive infinity, while the right-hand limit is negative infinity. Therefore, the limit as x approaches -1 does not exist. There is another discontinuity at x equals 0. But both the left-hand limit and right-hand limit at that point is 0. Therefore, the limit as x approaches 0 equals 0. And the limit as x approaches +1 is 1. Let's work on another one. For this graph, find the limit as x approaches 0, and positive infinity. I encourage you to pause the video, and try it yourself before continuing. Now that you had a chance to try the problem, let's take a look. There is a discontinuity at x equals 0. Instead of -1, g of x equals 0 at that point. But this doesn't mean the limit is 0. G of x approaches -1, from both the left and right, as x approaches 0. So the limit of g of x, as x approaches 0, is still -1. There is also an horizontal asymptote at y equals 1. As x approaches infinity, g of x approaches 1. For the last example, let's go in reverse. Draw a graph where no limit exists at x equals -1, and where the limit is 0 at x equals 1. For the limit to not exist, the left-hand limit must not equal the right-hand limit. So you might get something like this. And at x equals 1, both the graph must approach 0 from both the left and right side. So the graph might look something like this. This is just an example graph. There are many possibilities, and being able to understand derivatives will help give a better prediction of how a graph looks like. But before we move on to derivatives, join me in part 2 to go over how to find limits given a function. I hope this was helpful. Feel free to reach out to me if you need any more help. I'll see you next time.